10A, we're going to look at scatterplots as a way to look at a relationship between two variables. This is something that you probably did in Algebra 1 and or Algebra 2. Um, so we are, in this class, your things are you need to be able to describe the direction, form, and strength of association. And so I'll explain what each of those means, but those are the three things that you need to be able to identify and describe. Okay, we're going to use the same terms that we did when we talked about experiments. Response variable is the outcome or result, so that would be like your dependent variable in science. And then explanatory variable is the one that we think can explain or cause a change in the response variable, so that would be your independent. Okay, so response is dependent, explanatory is independent. Okay, so three things you need to be able to describe. Direction. For our purposes, positive, negative, or none. Okay, if the dots are mostly going up as we go left to right, that would be positive. If they're going down, that would be negative. If they're just kind of all over the place, then there's no correlation. Okay, when we talk about the form of the association, it's either linear or nonlinear. Okay, so is it pretty much making a line, or is it clearly making a curved pattern? And then lastly, the strength of the association. So this has to do with how tightly packed my dots are. If I tried to draw a line through the middle of them, would most of the dots be very, very close? Or if I did my best to draw a line through the middle, would there be some dots that are further away from the line, right? So these are really close. This is a strong association. This one, I have some that are further away, so this would be a weak correlation. And we have something that we can use to actually measure and give a numerical value, and that is called the correlation coefficient. Okay, the symbol is the letter R. So when we see in Desmos, or if you used your graphing calculator in the past, it's that one that says R, and it measures the strength of a linear relationship. So it is always somewhere between -1 and +1, and the closer it is to one of those values, the stronger the relationship is. Okay, so if it's like 0.8, 0.9, those would be really strong relationships. If it's closer to 0, like 0.2, 0.3, those would be like weak relationships. All right, and so one of the ways that we can see what the line looks like and get our R value, we're going to use Desmos because it is much, much easier. So what we're going to do is open up Desmos here, and we need to get a table. So we click this plus sign up here and choose table. All right, and so I'm going to type the X values in this first column. I'm just copying from, oops, this should be 3, 24, 30. Let me delete this one. All right, and then my Y values are going to go over here. And you can see it starting to come up with some dots over there. It is actually graphing each of these ordered pairs. All right, so let me zoom this out a little bit so we can see. All right, so there is all my dots. If we talk about being able to describe the three things we talked about, direction, I would call this negative. All right, form, that's pretty linear, can almost make a line. And then strength, I don't know, maybe moderate, maybe strong. We'll see when we see what R looks like. Okay, but there's my scatter plot of this data of years out of school versus annual contribution. Okay, now if I go to the next line, I'm going to type in this expression here, and that's going to give me my line of best fit. So Y1, if you just type Y1, it'll automatically pop it down like a subscript. So you don't have to worry about making it smaller. It automatically does it. And then this symbol right here, this is called a tilde. It is right next to the 1 on your keyboard, but you have to press Shift. So Shift and the key next to 1 will give you the tilde. And then MX1 plus B. Okay, and you see it gives me M and B. All right, so that's going to help me write my equation. And then R is negative 0.91. All right, so that means this is actually a very strong relationship. And if you look at the line that it drew, all those dots are really close to that line. Okay, so that makes sense. All right, so if we were going to write the equation for this, it would be y equals negative 0.38, we'll round to 2 decimal places, x, so negative 0.38x plus 12.88. Okay, that would be my equation. Right? Then the other thing you need to be able to do is use this equation to find predicted values. And this is another great benefit of Desmos is it makes this much easier to do. So if we wanted to say, let's say we want to use this and we want to know how much would the annual contribution be for someone who had been out of school for 12 years. Okay, well 12 is an x value. So when you did this in Algebra 1 and Algebra 2, you took your equation, you wrote it down, you plugged 12 in for x, and you did the math. But Desmos makes this a lot easier. Okay, if I'm plugging in 12 for x, I can come down here and just type x equals 12. And this point right here where x equals 12 intersects with my line of best fit, that's the number. All right, so a person who has been out of school for 12 years would have an estimated annual contribution of 8.31. All right. We can do the same thing with Y values. So if I wanted to know someone made an annual contribution of, I don't know, 15. How many years do we think they've been out of school? Well, annual contribution is a Y value. So I'm going to type Y equals 15. And then I'm looking for where that intersects with my blue line of best fit. Okay, and this says negative 5.59. Well, clearly in this case 15 doesn't make sense because I couldn't have someone who's been out of school for negative 5 years. All right, but you get the idea. We can plug in both x and y values much easier than we could with your traditional graphing calculator. Okay, and it makes that math so much easier. All right, and that is it for 10A.